Good morning, all the students of 7th standard. We are learning here geography's 5th lesson, wind. This lesson we are learning, and this is the last lesson of our syllabus. 1 minute. So page number 21 is going on, and in the page number 20, on the page number 21, next point, geographical explanation is there. We have learned that the air pressure is not uniform across the earth's surface. This we know that air surface is not uniform. Uniform means what? Air surface is not the same everywhere on the earth's surface. Air pressure is different, various according to the earth's surface, that according to altitude, the geographical region, area, and climate, atmosphere. So for these factors are important, they influence the air pressure. That so when we are on the earth's surface, on the ground, air pressure is more, but when we go on the high altitude, that time air pressure is less there. So air moves from high pressure areas toward the low pressure. What the air is there? From the high pressure areas toward the lower pressure areas. Air, it moves there from the high pressure toward the low pressure, like in this way it moves there. Where the high pressure is there, from there it will move toward the low pressure areas there. Originally, direction of the air from the high pressures to the low pressures, and change the directions because of the rotation. And why the direction of the air pressure it's changed? Because of the rotation of the earth. So changes in the wind, these are also some point of figure is here, how the direction is changed of the airs according to the altitude, according to the degree there. So next point, areas in a horizon manner that winds are generated due to this moment, due to the air, due to the earth surface there. What are the winds are there? They are generated on the earth. The extent of the difference in the air pressure affect the velocity of the wind. Extent of the differences into the air pressure, it's affect the velocity. Velocity we can call as the speed of the wind. It's affect the velocity, or it's affect the wind speed there. If there is a less differences in the air pressures, wind blow with the less velocity. If less pressure is there, then obviously wind also blow with the less pressure. If the more pressure is there, then what will happen? Wind also blow with the more pressure there, or with the more velocity. Speed will be more there. It will be more there. If pressure is more, speed is more. If the pressure is less, then speed is less. In this way, simple thing is there. So next, winds blow with a greater velocity if the pressure differences is greater, and if the pressure difference is great, then a wind pressure with what is there, with a great velocity. If more pressure, then more velocity. For example, a simple thing we can say that in our home, ceiling fan is there. If the fan speed is less, then air also that will not get that much with the fast pressures. It will not come down, so slowly it will come. Light air will get. And if we increase the fan speed, then more air will get downside, will be pulled down. We feel the difference. Wind speed also varies like in the same way. Wind velocity is measured in the unit of knots. So wind is measured, wind speed or the velocity of the wind, speed of the wind is measured into the knots. How we measure the speed of that vehicles into the kilometer per hour, like same with the wind velocity or the speed of the wind is also measured in the unit of knot there, or kilometer per hour. What the wind speed is there? Kilometer per hour. Knots are also we can measure into the kilometer per hour. Give it a try there. Write the changes directions of the wind in the table below. Pressure belt, mid latitude and the pole in that regions, North Pole hemisphere, South Pole hemisphere. In this way, how the winds it's change the direction, that we have to write here. When we consider the earth as a whole, we define the direction of the wind is influenced by the rotation of the earth. So what is here? When we consider the earth, when we consider our earth as a whole, our earth is a whole, it is rounded there. When we consider this one, And then we find the different directions into the wind influenced by the rotation of the earth. It influenced to the rotation of the earth that winds gets deflected toward the right of their original directions. And what are the winds are there? They get deflected toward their right toward their original directions to move there. Where in the southern hemisphere they get deflected toward the left directions. So what is there into the northern hemisphere to their right, it will be take them to the southern hemisphere toward their left. If we are into the south hemisphere, winds will go toward the left. If we are into the north hemisphere, it will go toward the right directions. Like you see, differences is there. Now, so if they are into the northern hemisphere, it deflect toward the right directions there, their original directions. This directions has been shown by the curve arrows in the figures 5.2. In that figure 5.2, in this figure we can see the differences, or we can understand the changes into the directions here of the wind. So the next previous on the page you will get that the rotation of from the west to east causes these changes in the original direction of the wind. Rotation is there of the west to east. It's caused the changes into the wind there. Now the next point is there. Observe the figure 5.3 and answer the question that which are the winds in the northern hemisphere that blow from the mid-latitudinal high pressure belt to the equatorial low pressure belt. So here the question is there, which are the winds are there in the northern hemisphere that blow from the mid-latitude high pressure belt. Mid-latitude high pressure belt, it is on the 35 degrees degree there. We can see that into the northern side. High pressure belt toward the equatorial low pressure belt. So from easterlies winds, they blow from mid-latitude toward the equatorial low pressure, from the high pressure toward the low pressures. Easterlies winds they blow that. What is the direction of the westerlies in the southern hemisphere? What is the westerlies winds are there into the southern hemisphere? What is the direction of the left side there in the southern hemisphere? Which planetary winds blow from the mid-latitude high pressure belt toward the subpolar low pressure belts in the northern hemisphere? Westerlies. Mid-latitude toward the subpolar low pressure belt, there's westerlies winds blow there. Which planetary winds, for this figure 5.3 we have to see properly, which planetary winds blow from the mid-latitude high pressure belt toward the subpolar low pressure belt into the northern hemisphere? Sorry, next question, second question, what is the direction of the westerlies in the southern hemisphere? Westerlies wind into the southern hemisphere that we have seen into that left side there. Which planetary winds blow from the mid-latitude high pressure belt to the subpolar low pressure belt into the northern hemisphere? That is northern hemisphere means upside there, westerlies wind there. Why is the direction of the polar wind not the same in the both the hemisphere? Because of the changing places and the pressures, the direction is not same there. Name the winds that blow in the southern hemispheres. Which wind blow in the southern hemisphere? Westerlies wind blows into the southern hemisphere. The subpolar low pressure belt, polar winds are in the westerlies. You've seen that. In which directions do the easterlies blow in the north and the south hemisphere? Easterlies. Right side of easterlies, they ask that easterlies toward them is our, if you see then our left side, in the left side directions. So figure 5.3 we have to observe, we have to study in a proper way, and once you understand this figure then you are able to solve it. The next point here, winds are known by the different by the directions from which they blow. Whatever the winds are there, they are known that they called by the directions from which direction they are blowing, in which direction they are blowing. On that direction side they recognize, they consider that, for example, westerlies are winds that blow from the west. Westerlies means they are blowing toward the west side. The direction of the blowing, the durations, the regions covered, and the condition of the air determines are the following winds right there. So what is the wind types are there? Means here given there some of the wind types there. How we determine the wind type there? Okay. So what we will do? The direction of the blowing, how they are blowing, the durations, regions, the conditions. All this we will see in the next video. Thank you very much. Bye.